In this lab, I'm going to talk about how to analyze data that you collected from the Hooke's Law lab in class. So I'm going to type in some displacement data. Now I'm going to show you a couple tricks along the way here. So let's just say you collected data in centimeters, because that might have been what you've collected. I'm going to show you a couple tricks on how to convert information. And let's say you collected the mass in kilograms, because those are what you hung on the springs. So I'm going to say 0 centimeters, -2, -4, and I'm just going to put in a pattern here. So this is just dummy information. And let's say the mass you put on was 0, 100, 200, and so forth. Okay. There you go. Now what you want to plot is y in meters, not centimeters, and force in newtons, not kilograms. Okay. So for the displacement here, this is in centimeters, or you might have done millimeters, but this is in centimeters, so I basically want to divide by 100. So I'm going to show you a little Excel trick. I'm going to put 100 right here. I'm going to copy that, and then I'm going to highlight these guys and say Edit, Paste Special, not Paste, but Paste Special. And I can actually divide by that number I copied, or 100. So I can convert those all to centimeters, or excuse me, to meters. And I'm going to just copy those and put them right here. Force is the number of kilograms times 9.8. So right here I have kilograms, but I want to get them so that they're these values times 9.8. Actually, these numbers are probably really big. These might be grams. So I can play that same little trick here. I can convert these to kilograms by dividing by 1,000. So I'm going to say copy that 100. Actually, it's going to be 1,000. 1,000 this time for kilograms. Copy that 1,000. Take these guys and go Edit, Paste Special, and divide by 1,000. So there's my kilograms. But newtons are these numbers times 9.8. So I'm going to take 9.8 here. I can copy these numbers, or copy that 9.8, and then do a multiply. Edit, Paste Special, multiply. So there's my numbers in newtons. Copy that, put that there, and now this information is pretty much necessary. I don't need that. These are the real values. These are in meters, negative because the displacement was down, force in newtons pointing up. So what I'll do now here is I will highlight the information, do Insert Chart, click XY Scatter. We won't connect the dots. We'll just leave it as is so we can see a pattern. Step 1, or excuse me, Step 2 is basically confirming what I've highlighted, so that's okay. Click Next. Chart title, I'll say figure 2. This is force versus displacement for, let's say, the single spring. The x-axis is displacement in meters, and the y-axis or vertical axis is force in newtons, which is what we put in there. I'll click Next, and I can create this as a new sheet, or basically a new 8.5 by 11 piece of paper, or I can just create it right here as an object in the sheet. So I'll click that, and there it is, nicely formatted and everything. We need to create a mathematical model. So I'm looking at this and it looks like it's linear to me. And the way you create a mathematical model in Excel is you right click on a data point. So I'm going to click on a data point, right click it. And I can add a trend line. So basically I can pick linear polynomial type plots here. I think it's linear. And the option I'm going to choose is to show the equation on the chart. If I know the data actually goes through 0, that I can set the intercept to 0, which will force the curve fitting function in Excel to put it through 0, but that's not necessarily true if you don't have an ideal spring where you have that y-intercept. So I'll just click OK here. And there's my equation, and it's not quite the way I want it to look at, so I'm going to make the font bigger. Let's say 20. And I want, this is a mathematical formula. In physics, this would be force as a function of y equals -49 y, and this is basically 0, but I'll leave it there. 4 times 10 to the minus 15th. Put the newtons there, and there's my mathematical model. To print this information, so if I click print preview right now, it's just going to print that graph, but it would be nice if I could print this data, and I should probably put a table number here, table 1, displacement versus, force, single spring, okay, and it would be nice if I could put this on one page. So what I can do is I can actually highlight what I want to print. I can nudge this over a little bit. Oops, nudge this over a little bit so that it falls within this column there. So highlight this again. And then in Excel I can say File, Print Area, and I can set a print area. I can say just print this area. Set that. And I can preview it. And it's kind of cut off, but I can edit this a little bit. I can click Setup. And the really cool feature of Excel is I can say fit to 1 by 1. So it's going to squeeze this in, make it fit 1 by 1. Click OK. And there it is. If you make this graph smaller, maybe squeeze some things up, you might be able to fit 2 on a page, so you can see that very clearly. Else you can say maybe go landscape. I think portrait's a little bit better. At any rate, setup allows you to fit those graphs and data tables on one page. Go back, close. So that's a real quick summary of how to analyze the data in Lab 3. I had some raw data here in units I didn't necessarily want. I can copy and paste special to convert, put them into a new table, the correct values and units, create a chart, add a trend line, titles, units, everything around here, and will get you the graph for Lab 3.